This is the next video in the course on software development guidelines for Flames software development. In this video, I'm going to talk to you about some specific things related to programming in C and in C++. So I'm getting the information here. I'm referring to the information in the developer manual called the Flames Development Guide. And there's a section in there called Programming Languages. So after this video is over, if you want to go back and look at it, you can go to this manual and find it. I'm going to look at programming in C first. Now, I'm not going to cover all the information that's in this topic because none of the code that's in the Flames software repositories is written in C. There's a few very minor exceptions. It's all written in C++, and C++ is the language that we recommend you use for Flames component class development. But Flames kernel, Flames itself, the base classes in Flames and all the Flames framework functions that you can call, they're all written in C. And if you want to know more about why we chose to do that, you can go back to the video on the Flames class hierarchy, and I talk a little bit more about why we chose to do that. If we were to write Flames over again, we would absolutely write Flames in C again. It is definitely a better language for writing a framework than C++ is. We don't recommend that you write your models in C, but I do want to tell you a little bit about some things that are going to be important to understand because Flames is written in C. So I'm going to go down to the to how we define member functions. So in C++, there's a very specific syntax for defining member functions of a class. In Flames, we don't have the concept of a member function, but we have a very specific naming convention that helps us know when a particular function is a member of a particular class. And for that, we always name the function the name of the class, just as if this was the C++ class. And then there'll be the actual function name after it. So this is alter, for example. And you already know about the general naming conventions for Flames, that we have a noun and a verb, and then optionally an object of the verb. So we followed that convention. So it's real easy to look at the name of the function and get a little bit of an idea for what the function does. Big point I want to make at this stage is to tell you about the convention that we have for Flames member functions that are written in C. The first argument to the function, if it's a function, a member function of a class, is always an instance of the class. So we've named it here lowercase this to kind of make it look like it's a C++ thing. In C++, the object is passed into the function implicitly, and you don't have to specify it as an explicit formal argument. But of course, you can't do that in C, so our convention is to always pass in the instance of the object on which this function is supposed to operate as the first argument. So that's universal throughout all of the Flames functions. Whenever the function is a member of a class, there'll be some functions that we have that are just utility functions that are not member functions of a class, but most functions are members of a class. So the first argument is always an instance of that. It's just, again, all the way across. And that's going to be true in C, as if you're calling it from C or from C++, it doesn't matter. Now the other thing, so that's the main thing that I want to tell you. You can go look here. If you're actually writing a class in C, we have some older applications that we wrote where we wrote models in C, and you won't find that source code in the repository, but you might be working on one of the simulations that somebody built with Flames years ago, or that we built using Flames, and you might have access to that source code, and that code might be written in C. And you might be curious, well, how do you do inheritance in C? And how do you do encapsulation? How do you do polymorphism? And most people don't realize it, but you can do all of those things very nicely in C. C is a very flexible language. And we do that in all of the classes that are internal to Flames. So this particular topic in the Guide to Customization tells you a little bit more about how we do that, how we do inheritance, how we do member functions. But I'm not going to talk about any more about this because, again, you're probably not going to be doing that. The main thing I want you to do is understand how to call flames functions. And the reason that I want to make sure you understand that is because that applies to code written in C++, just like it does in C. So let's go to C++. In C++, the thing that you need to understand is that when you're calling a function that's a member function of a flames defined class, any flames defined class, even if it's a class that's written in C++, you'll never call the function using the standard member function calling mechanism. So for example, if you had a sensor class and so say FCPP sensor class, so here's an object of that, and you had an alter method, this would be the way that you could call the alter member function of that class. Now, if you are writing your class in C++ and you're calling a function of yours that is written in C++, by all means, use the normal C syntax. But if the member function is actually implementing one of the member functions that comes from an abstract class that you inherited from Flames, for example, alter, you should never call that function using the C++ calling mechanism, which is the class object with the dereference operator and then the name of the member function. Never ever do that for a Flames defined function, whether it's a C++ function or C++ class or a C class. It doesn't matter. You should always call the C version of that member function. So instead of calling alter like this, the alter is actually a method implemented by the Flames fEntity class. So every class that descends from that has the opportunity to implement the alter member function. So when you call it, you would never call it directly. You would always call it through the fEntity normal C function. And you'd pass in an instance of the object as the first argument. So all the fEntity functions, even though you could invoke them this way, never do that if it's a Flames defined member function. You would always do it through this. And Flames has a C function like this for every single member function that it has, that it defines for every single class that it defines that you inherit or that is out there for you to use. So you always call it this way. And I'll just give you a little bit of background as to why we do this. One of the limitations of C++, or maybe I should say one of the advantages of C, is that you can implement member functions that in a parent class that actually get extended by the subclass rather than replaced. So normally when you define a virtual member function in a parent C++ class, and you could have a default implementation of it, but then if a child class implements that, it replaces the default implementation and you use the child's class implementation of it. And that's how you get the polymorphic behavior of object-oriented programming. In C, we can support that same capability, but rather than having the default implementation of the virtual member function getting replaced, we can have the subclass's implementation of the member function augment the implementation of the parent class. So every time you call fEntity alter, we can do some things at the entity level class before we call the subclass's specific implementation of alter. So that's why we do it. We do that quite a bit. So our parent classes have a lot of built-in behavior. The methods of our parent classes have a lot of built-in behavior that always gets invoked every time the method gets invoked, which is why you always have to call any Flames member function using the Flames way. And then you pass in your instance of the object as the first argument, as is always the case. So it's this particular practice is universal in all of the code that is in the Flames repository. So every model that you pull out of there, every component class will always call things this way. So if you use that code as your example for how you write your code, you'll be fine. If you aren't paying attention to this documentation and you all go off on your own and try to do something, you're going to end up causing problems for yourself. So That's why we have this section in this manual and this particular video to make sure that we make this point very strongly. Again, if you are defining your own classes with your own member functions, they're not implementations of Flames class virtual member functions. Call them any way you want. But if it's an implementation of a Flames virtual member function, call it the way I just described in this video. Thank you for watching, and thank you for using Flames.